Hello guys, I know you are in the exam season and want to learn difficult concepts in a fast pace. And today I am here to make those concepts easy for you. For today I want to teach you the chain rule, which is one of the most useful rules in derivatives. In order to start working on the chain rule, I like to show you some examples, and based on those examples you will be a master in chain rule. So no worries, after watching this video and doing some practices, chain rule will be super easy. Now the first question, when we need to use the chain rule? When we see a complicated function which is basically a function inside a larger outer function. In that case we need to use the chain rule, which makes your life easier and you save a lot of time in taking the derivatives of complicated functions. Now let's look at the first example that we have here, which is 2x plus 10, and for here this is going to be our inner function in power of 10, which is going to be basically the outer function. When we are talking about the chain rule, we are dealing with an inner and outer function, and the rule says it is best to take the derivative of outside function, which is here the 10, and then keep the inside as it is, and then times it or multiply it with the derivative of inside function. And for this case, for the outside function, we have to use the power rule, and power rule, as you know, says when we have a variable to the power of n, we have to bring that power as a coefficient, which is going to be n, x to the power of n minus 1, so we reduce the power by 1, as you can see here. So for this case we can easily apply this rule. So the derivative of this function, which is going to be du over dx, is going to be the derivative of outer function or outside function, which is 10 times 2x plus 10. So we are keeping the inside function as it is, and 10 minus 1, and then the second part is going to be the derivative of the inside function, which is 2x plus 10, and the derivative of that is going to be just 2. So finally we get du over dx equals 20 2x plus 10 to the power of 9. So let's have a quick review for what we did here. We have an inside function of 2x plus 10, as you can see here, and this function is basically going to be in power of 10, and based on the chain rule we have to take the derivative of outside function and keep the inside function as it is, and then multiply it with the derivative of inside function, as you can see in this example. So first we took the derivative of outside function, which is going to be 10 and 2x plus 10 to the power of 10 minus 1, and we used the power rule. And then we took the derivative of inside function, which is 2x plus 10, and the derivative of that is going to be 2. So at the end we will have 20 times 2x plus 10 to the power of 9. Let's look at the second example here, and we want to use the same rule, which is basically the chain rule. Now for this one we have x cubed plus 2x to the power of 9. So the same rule applies here. First we need to take the derivative of outside function, which is going to be the power of 9, and the whole function, assuming that it is going to be like u for us, or let's say p for here, the whole function inside, and I'm calling it inside function. So p is in power of 9, so basically again we have to use the power rule. Therefore for here we have du over dx equals to 9x cubed plus 2x to the power of 9 minus 1 we have to reduce the power basically. 9 minus 1 times the derivative of the inner function. So times the derivative of inner function, which is 3x squared plus 2. So if the question is asking for the simplification, you have to do the simplification. Otherwise, just writing this should be fine. Du over dx equal to 9 times 3x squared plus 2 times x cubed plus 2x to the power of 8. So again, this problem was showing that how we can use the chain rule to this type of function. We first assume that we have an inner function which is x cubed plus 2x, and we have an outer function which is the whole function to the power of 9. And first we use the power rule for the assuming that x cubed plus 2x is equal to p to the power of 9, and then based on the power rule we will have 9x cubed plus 2x, 9 minus 1, and then we took the derivative of inside function which is 3x squared plus 2, and at the end we get the final answer which is here. As you can see, this big function here. So for some cases you can write u prime or you can write du over dx. Both are correct and common representation for the derivative with respect to x. Now let's look at the other examples that we have. This time we have a trigonometric function, cosine of x cubed x squared minus 3x. So as you can see here, we have the function of cosine, which is here the outside function for us, and we have x to the power of 2 minus 3x, which is going to be the inside function for us. And based on the chain rule, we have to take the derivative of the outside function first, and we know that the derivative of cosine x is, let's write it as here, du over dx equals to u prime equals to minus sine, and we have to keep the inside function as it is, x2 minus x to the power of 2 minus 3x, and then for the inside term it's time to take the derivative based on the chain rule, so times 2x minus 3. So you see that easily we got the final answer basically, because it's going to be u prime minus 2x minus 3 sine x squared minus 3x. So we looked at outside function first, which is the cosine, and then we took the derivative of the inside function and we multiplied both of them, and we got the final answer as you can see here. And when basically should we use the chain rule? So anytime we can apply it, or sometimes we need to use it. The answer is that basically the chain rule helps you to save the time in taking the derivatives. For example, here we have x cubed plus 2x to the power of 9. So you can apply the power here and open it up, but it takes time in order to do that. So the best thing is to use the chain rule for this case. What about x to the power of 2? Easily you can take the derivative of that, so no need to use the chain rule. So there is no need to use the chain rule for this case. Let's look at the other example. We have x plus 1 to the power of 9. Again, you see here there is no coefficient here for x. So you can use the chain rule, or you can easily say that the function inside, maybe we can call it p, and it is basically, we can write it u equal to p to the power of 9, and p is basically x plus 1. So at the end it's going to be 9p to the power of 8. So we just plug in x plus 1 instead of p, so we get x plus 1 to the power of 8. So the answer is going to be 9x plus 1 to the power of 8. Or you can use the chain rule here easily again. So assuming that you have outside and inside function, and doing the chain rule will give you the same answer. And for the last example, you see that we have 3x plus 2. Again, no need to use the chain rule, because easily you can take the derivative of this function here, which is 3x, and basically it is a constant number times x, and we know that the derivative of a constant is going to be 3. So the general rule says d over dx cx is equal to c. So now you have to be able to use the chain rule for any form of complicated function which contains an inner function inside an outer function.